You've seen how we can take the gases from the air and use them, the carbon dioxide, the nitrogen and the oxygen. Let's see what we can get from the other resources of the earth, the rocks and minerals of the mountains and deserts and the chemicals out of the sea. If you take these rocks and minerals here and you do the right things to them, this one will in actual fact give you lead. And this one, if you do the right things to it, will give you copper. And copper's used in electrical wiring and pipes. It's a very useful metal. Earlier this morning we did a reaction where we took an ore of iron and mixed it with aluminium to get molten iron out of the rock and mineral. And here you can see me putting this mixture into the flower pot. Mike here is warming up some glycerol, and this will start the reaction like a fuse with the potassium permanganate oxidizing agent, and then within 20 or 30 seconds he's got to get out of the area because this violent reaction will occur, and we hope that we'll see molten iron at 1500 degrees C pouring out of the bottom of the flower pot. You can see the white hot sparks of the molten iron, which, as I said, is at 1500 degrees. And in the bottom there, on the pieces of metal, you can see the now cooling lump of molten iron. That reaction that you've just seen is very like the one that is carried out in the steelworks, where they take iron ore and carbon and they use those to make iron by extracting it. And you can see the molten iron being made, and you'll see it streaming out the bottom of the reactor just like it did out of my flower pot, and it's then run off and cooled and rolled into sheets and bars of metal for all sorts of uses. And I want you to think for a minute just how much we get from the rocks and the minerals, because these give you the metals. This one lead, this one copper, other ones. And just think of all the things that are made of metals. Everyday objects like knives and forks and saucepans, but things like tools and scalpels for surgeons, and calculators and televisions and electric cabling and piping and cars and bridges and planes and girders for buildings. The world wouldn't be the same without being able to get the metals out of these rocks and minerals. So, the earth gives us our metals. Mike's going to tell you what the sea can give us.
Well, so far we've been concentrating on the air and on the solid resources that are present in the earth. We haven't said very much about what's available in the sea. Now, I'm sure you know that sea contains an awful lot of dissolved salt, sodium chloride, but it also contains a variety of other minerals. Salt can be turned into other useful chemicals. It's useful as itself, but it can be turned into other useful chemicals, and I can show you that reaction here, producing sometimes called salt gas, but its chemical name is hydrogen chloride. This gas you can see forming steamy fumes as it comes into contact with the air. Now, this gas is particularly soluble in water. It's very, very soluble in water, and one experiment that we can show you to demonstrate that is sometimes called the fountain experiment. And Anne and John are going to demonstrate this now. In the bottom flask, we've got water that's coloured blue with an acid-base indicator. And in the top flask, we've got some hydrogen chloride gas. So the hydrogen chloride dissolves in the water, it pulls the water up into it, and at the same time it forms an acid solution which changes the colour of the indicator from blue to yellow. And this is a simple demonstration, or a relatively simple demonstration, to show how soluble the gas is. It's also possible to extract other useful chemicals from sodium chloride by a process of electrolysis. And here we've got an electrolysis cell, which is similar to the one that's used in industry, but it's scaled down. At one electrode, we're producing chlorine gas, and at the other electrode, sodium hydroxide will be produced. Now eventually the chlorine gas will come into the space above the two electrodes and it will colour the litmus indicator. It'll change it from blue to red and eventually bleach it. Right, now chlorine is an extremely reactive element. Chemically it's very reactive, it can combine with a lot of other things. And we're going to show you some simple experiments here which illustrate how it can combine. The first one is to take an alloy which contains mostly copper and to just allow the copper and the chlorine to come into contact with each other. Now as you can see there's an instant reaction producing clouds of a new chemical. Another reaction we can show you is a naturally occurring material, turpentine. When this reacts with chlorine, it burns, as you can see, and produces carbon, which is one of the elements that turpentine contains.
As you've just seen, the chlorine is a very, very reactive gas. And this green gas will kill you if you get enough of it. But you've got a lot of cells in your body, and so you can afford to come in contact with a few molecules of chlorine. But if you were a bacteria with only one tiny cell and a few molecules of chlorine hit you, that would be the end of it. They'd rip you apart. And that's one of the main uses of chlorine. Chlorine is used to make bleach, but every drop of water that you drink out of a tap in this country has been treated with chlorine to make sure it's killed all the bacteria. If you lived in an underdeveloped country and you had to get your water from a well, like the people that Oxfam worry about, then you can't guarantee that the water is bacteria-free because it hasn't been treated with chlorine. Chlorine is also used to make things called CFCs, which are chlorofluorocarbon compounds. And they're used in spray cans and they're also used in fridges. And over the Antarctic, they've recently discovered a hole in the ozone layer. And this is thought to be due to these fluorochloro compounds. And chemistry is about understanding our very complicated atmosphere. Our air, the clouds, the gases in it are very important to us, and if you want to understand what's going on, then you've got to understand how the molecules are behaving so that you can then find out about holes in the ozone and, if possible, mend them. What we've shown you is just a beginning. We've shown you how we can take the rocks and the minerals from the earth and make the metals. We can show you how we can take the chlorine and the sodium chloride from the sea and turn them into useful things. We've shown you how we can take the gases from the air and begin to use them to make useful things. And what we're going to show you in the second part of this video is how we can put these ideas together on the way molecules behave and discover new and more useful things from our planet, the Earth, because that's what chemistry is about.